5.7, solving logarithmic and exponential functions. So we're just going to go through a bunch of different strategies on ways you can approach them. So first one, we have log base 3 of 9x plus log base 3 of x equals 4. So because they have the same base, we can combine them using our multiplication rule. So we have 9x times x. So we have log base 3 of 9x squared equals 4. Let's change it into an exponent. So we have 3 to the power of 4 equals 9x squared. It's just 9x squared. I didn't mean to make it to the power of 9. Okay, 3 to the power of 4 is, what is that, 81? So 81 equals 9x squared divided by 9, and we get 9 is equal to x squared, square root, and we get plus or minus 3 is equal to x. You need to be really careful here to test both your answers to make sure that they both work. So x equals 3 works. But you cannot take a logarithm of a negative number. It becomes undefined. So if I plug in log base 3 of 9 times negative 3, that makes it negative, so it doesn't work. If we plugged it into the log base 3 of x, it becomes negative. It doesn't work. So x minus equals minus 3 is extraneous. It is an extra root. The 3 will work. It works in both of those situations. So x equals 3. So just check to make sure it does not make it negative. Alright, log of 6x equals log of x plus 6 and log of x minus 1. So because this is a multiplication, we have log 6x equals log of x plus 6 times x minus 1. And something that you're able to do when you have logs of the same base and a single term on each side, you can actually, it's not that you're canceling, you can just skip a bunch of steps and you can rewrite it without the logarithms. So we can say 6x is equal to x plus 6 times x minus 1. There are ways to show this, but this skips all the steps. And now we would distribute. So we have 6x equals x squared plus minus x plus 6x, so plus 5x minus 6. We're going to divide by, nope, why would we do that? We're going to subtract 6x. So 0 equals x squared minus x minus 6. We're going to factor two numbers to make negative 1, multiply to make negative 6. They're going to be negative 3 plus 2. So we have 0 equals x minus 3, x plus 2. So our roots can either be 3 or negative 2. So we're going to check these up here. So if I plug in a log of 6 times 3, it makes it positive, it's fine. We have a log of 3 plus 6, that's still positive. And we have a log of 3 minus 1, that's still positive. If we go log of 6 times negative 2, that's going to be negative. We already have one negative, so we know this is an extraneous answer. So x equals 3. So I do want to show you the steps of how we get to canceling the logs. So what we would do first is we would subtract a log 6x from both sides. So we have 0 equals log of x plus 6 times x minus 1, and because it's a subtraction, we're going to divide by 6x. This is the same as having a base of 10, so we're going to now change it into an exponent, so I would have 10 to the power of 0 equals x plus 6, x minus 1 over 6x. This 10 to the power of 0 is 1, so we have 1 equals x plus 6, x minus 1, and then we times both sides by 6x to cancel. So we'd have 6x equals x minus 6, x minus 1, which is exactly where we got, but this is actually how you would do that step. You do not have to do all of that work though. You can go right into canceling your logarithms, but it does let you, that is why it works. Okay, let's do the other one. We have 3 equals log base 2 of x plus 2 plus log base 2 of x. So first of all, the thing that I'm going to want to do is make it all have the same bases. So I want to rewrite 3 to be log base 2. So I'm going to say log base 2 of what equals 3. So it's 3 to the power of 2. 2 to the power of 3. I said that backwards. So we're again thinking about this. Log base 2 of what equals 3. So we would know 2 to the power of 3 equals 3. So that's how we get that step. On the right side, what I'm going to do is I'm going to combine those into one logarithm. So I have log base 2, it's adding, so I'm going to multiply, so x times x plus 2. And now that I have logs with the same bases, I do not need to write them anymore. So I have 2 to the power of 3 equals x times x plus 2. I know that 2 to the power of 3 is 8. I'll distribute this in, so we have x squared plus 2x. I'm going to minus 8 to the other side, so we have 0 equals x squared plus 2x subtract 8. I want two numbers that add up to make 2 and multiply to make negative 8. They are 4 and negative 2. So we have 0 equals x plus 4, x minus 2. So we know that x can equal negative 4, or it can equal 2. So we're going to just test to make sure that these work. So if we plug the negative 4 in, it's not going to work there because it would make it a negative, so that's extraneous. And 2 will work for both of them because it'll be positive as a positive 2 here, and 2 plus 2 is 4. So my answer is x equals 2. Alright, let's solve these. So we have 4 to the power of x equals 12. We can rewrite this as a logarithm, so log base 4 of 12 equals x. And then I can solve this by doing log of 12 divided by log of 4 will give us x. So it could be 1.792 dot 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 dot. And that is our x value. If you want to think about this in a different way, 4 to the power of x equals 12, we can take the log of both sides. So we have log of 4 to the power of x equals log of 12. X comes in front, so we have x log 4 equals log 12 divided by log 4, and we get to the exact same spot, but this way has less steps. So you can convert it into a logarithm and solve, or you can take the logarithm both sides and solve, but in the end you're probably going to get the same answer. Okay, next one. We're going to isolate that bracket by dividing both sides by 3. So we have 2 to the power of x plus 1 equals 12. I'm going to change this into a logarithm. So my base is 2. So log base 2 of 12 equals x plus 1. I'm going to subtract 1. So I have log base 2 of 12 minus 1 equals x. We're going to evaluate this by doing log of 12 divided by log of 2, and then we're going to subtract 1 from our answer, and we get 2.5849 dot 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 dot. So that is how you can solve that question. You can also solve it by taking the logarithm of both sides. Both ways will work. Okay, we have 3 to the power of x plus 1 equals 6 to the power of x. So the only way we can do this one is by taking the logarithm of both sides. So I'm going to take the log of 3x plus 1, and I'm going to take the log of 6. And I'm going to bring that x plus 1 in front. So I have x plus 1 log 3 equals log 6. Then what I'm going to do is I'm going to distribute this in. So I'm going to have x log 3 plus log 3. 1 log 3 equals log 6. From here, what I'm going to do is I'm going to isolate my x values. Oh, this is to the power of 6. So we should actually move that in front. X log 6. We're going to put the things that have the x's together and the things that don't have the x's together. So I'm going to move this x log 6, 3, to the other side. So I'm left with log of 3 equals x log 6 minus x log 3. Now I'm going to take out a common factor, which is x. So I have log of 3 is equal to x log of 6 minus log of 3. I know that I can rewrite that as a division statement, so I can go x of log of 6 divided by 3, which is 2. And now I can get x by itself by dividing by log 2. So when I type that into a calculator, I get 1.58. So again, this step right here, 6 divided by 3 becomes 2. That's why we were able to write that. So our steps are to isolate, distribute, move the x's to one side, and then factor a little bit. Okay, last one, very similar to this one. We're going to take the log of both sides, so we have log of 2 to the power of x plus 3 equals log 6x minus 1. We're going to move the exponent in front for both. So we have x plus 3 log 2 and x minus 1 log 6. Now I'm going to distribute those in, so I have x log 2 plus 3 log 2 equals x log 6 minus log 6. Now I'm going to move the x's to one side and the non-x's to the other side. So I'm going to plus log x 6 to the other side. And I'm going to subtract x log 2 to the other side. So I should be left with 3 log 2 plus log 6 and x log 6 minus x log 2. Now I want to move, I don't want this here, I want it to come back over here. So I'm going to have log of 2 to the power of 3 plus log of 6. And I'm going to take an x out on this side, so I'm left with x log 6 minus log 2. 2 to the power of 3 is 8, and we are adding on this side, so I'm going to multiply. So I'm going to have log of 8 times 6. And on the other side, we're going to have x times log of 6 divided by 2. So we have log of 48 equals x log 3. Divide by the log of 3. And we get x to equal 3.52 dot 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 dot. So those are the most complicated for them, but that's about as complicated as it would get. So just practice. The more you do logarithms, the more enjoyable they get, I swear. I swear they get more enjoyable. Okay, see ya!